Hello and welcome to Chapter 8 of Statistics for Nursing. Today we are going to begin our analysis chapters. These are the chapters that are going to start using all that information you just learned in chapters 1 through 7. Let's take a look at our first analysis test, which is the chi-square. A chi-square is a statistical test that's used to examine the differences between independent groups when the outcome variable is at the nominal level. You knew those levels of measurement were going to come back, right? Now you have to look at what the outcome variable is in your study and determine if it's at the nominal level. Then you could use a chi-square test. The test itself compares the frequencies that are observed with the frequencies that would be expected if the two variables were independent or had no association. Let's think about when this might be a good test to use. In our example, the null hypothesis is there's no difference in the need for a postoperative transfusion among men and women. Your alternative hypothesis would be the need for postoperative transfusions is different for men and women. Whether the patients received the transfusion is a yes or no question, and whether they are male or female, again, is a nominal level variable. The degrees of freedom are a concept you're going to see throughout the remaining chapters of the course. It simply means that once you know a certain number of the variable values, then there's no longer any ability for the remaining ones to fluctuate or differ. The degrees of freedom for a chi-square test is calculated by taking the number of rows, minus 1, times the number of columns, minus 1. If we are comparing in a 2 by 2 table, like in our gender and transfusion example, that would be 1 degree of freedom, which is what we see in each. The number of rows is 2 minus 1, and the number of columns is 2 minus 1. 1 times 1 is 1 degree of freedom. The chi-square test, like all the others we're going to talk about, has an associated probability or p-value with its conclusion. If the p-value is less than alpha, it is significant, and you should reject the null hypothesis and report the significant differences do exist. That means we now have to go back and look at the variables themselves to see what those differences actually are. You can use the chi-square test to look at more than two groups, but remember, it doesn't tell you where the differences are, just that there are differences in the groups. There are times when we have an outcome variable at the nominal level when we shouldn't use a chi-square. That includes if one of the squares in our 2 by 2 tables, those are called cells, if one of those cells has a value less than 5. In that case, the numbers are so small that we need to make some changes on how we do the statistics. We would use the Fisher's exact test instead. When a cell has more than 5 but is still less than 10, it's still a very small number in that cell, so we're going to have to do a Yates continuity correction with the chi-square. And last but not least, if we have two samples we're comparing, but they're dependent samples and not independent samples, we would use what's called the McNemar's test. That's it for Chapter 8. Here's your chance to go apply the chi-square and start using the concepts we learned in the first 7 chapters. It's going to start pulling together, slowly but surely.